We're going to be using synthetic division to find the zeros of a polynomial function. So we'll start with the zero that we've been given. We've been given -2 as a zero of the polynomial f of x. And then we want to write down the coefficients of the polynomial in descending order. So 1 is the coefficient of the cubed term, -6 is the coefficient of the square term, -1 is the coefficient of the x term, and 30 is my constant. Now sometimes you're going to be given a problem where you don't have, say, one of the terms. So suppose you had no squared term. Then what you would have wanted to do here is put a 0 as a placeholder. And I didn't need to do that. Okay? All right, so the first thing we want to do then is, let me change colors here for you. And so we're going to always bring down the first term. And once we bring down the first term, after that it's just multiplying and adding. So -2 times +1 gives me -2. I add them together, I get -8. -2 times -8 gives me a +16. 16 plus a -1 is 15. -2 times 15 gives me -30. And I should get a 0 here because -2 is a 0, and that represents the remainder. Now, I always make sure I write down what degree polynomial I started out with. So this was a 3rd degree polynomial. Here, having a 0 of -2 using the synthetic division is the same as dividing by a factor of x plus 2. So when I divide x plus 2 into this polynomial f of x, when I divide a linear term x into a cubic, then my resulting answer, and we often call that the reduced polynomial, is 1 degree less. So this will be a 2nd degree. Once I'm down to a 2nd degree polynomial, I can either factor it using the tools I already know or use the quadratic formula. So in here, I'm just going to put this in with the erasing pen. So this would be the coefficient of the x squared term, the coefficient of the x term, and then the constant. All right, so let's write this other factor out. So I've got x squared minus 8x plus 15. Now, we said that we wanted these all to be linear factors so that I could find the zeros easily. So the first thing I want to do is factor this quadratic. I'm going to rewrite my first linear factor, and then I'm going to factor this. And so I know that x squared can be factored into x and x. And let's go back to the magic pen a second. So this being positive, and that was not what I wanted to do, tells us that both of the signs in here are the same, and this negative tells us that they're the same, but that they're both negative. So when we go back and put in here a negative and a negative. I need factors of 15 that when I combine them, they give me -8. So that would be a 5 and a 3 here. Okay? Now I notice here I've got all the linear factors. And so it's easy enough just to read off my zeros. So my zeros of my polynomial function f of x are x equals -2, x equals 5, and x equals 3. Now I can use this information along with the other information I already possess to graph this polynomial function. So I always want to think about what's the degree of my polynomial function. And so I know it's a 3rd degree. And let's go back up and look at the lead coefficient. So the lead coefficient was a +1, so I know the end behavior is going to look like this. I also want my y-intercept for the graph. Now, I could let x be 0 and plug it into the factor form, but it's much easier to go back here to my original form because my y-intercept is just the constant on the end. So I've got my y-intercept is 0, 30. And I did not want to do that. I forgot to switch pens. So let me go back, and that's 0, 30. Okay? Now, I'm ready to sketch a rough graph that shows the end behavior, the zeros, and the y-intercept. But it's not going to be accurate as far as local maxes and mins. All right, so I've got my graph here. And let's see, let's put our zeros on. So I've got a 0 and -2. I've got a 0 at positive 3, and I've got another one at 5. I know my end behavior, and I know that I have a y-intercept up at 30. I'm going to change colors here just for effect. And so my end behavior, I know I start down. I have a y-intercept at 30. I have a 0 at positive 3 and positive 5. And again, my local min and my max are not accurate, but I've got a good sketch of the end behavior and of the zeros of the graph and a y-intercept. All right, the next thing we're going to look at is a problem where perhaps you need a placeholder. So here, I'm given this cubic function, I'm given -4 as a 0. So I'll start by putting my 0 there. And now I'm going to put my coefficients in. Coefficient of my cube is 1, coefficient of my square, oh, there is no square term, so I'll put 0 as a placeholder for it. Coefficient of my linear term next to the first is -28, and my constant is -48. And if you recall, the first thing I always do next, well, besides making sure I write the degree, we've done 2/3 degrees, but we're going to be doing higher degree polynomials soon. So that's a 3rd degree polynomial. I bring down my lead term, and then it's just multiply and add. So -4 times +1 is -4. Add -4 and 0, I get -4. -4 times -4 is +16. Add +16 to -28, and I get -12. -4 times -12 is +48. I add those and get 0, which I should, because if -4 is a 0, when I put it into the function to evaluate it, I should get 0 as a remainder. All right, so now this reduced polynomial has degree 2. So now I can write my factors. This gives me a linear factor of x plus 4. If -4 is a 0, then x plus 4 is a factor. And here I end up with 1x squared minus 4x minus 12. And so I've got a quadratic here to factor. So let me bring down my linear factor. And let's see, my quadratic x squared factors into x and x. Let's see if I can use that magic pen to good avail again. So that's negative, so it tells me the signs are different. And it tells me that when I combine the two, I have to end up with a negative answer. Okay, so let's go back to the real pen. And so the signs are different, so I've got a positive and a negative. I need factors of 12 that when I subtract them give me a -4. So I'm going to put the -6 here and a +2. Let's just check this with the magic pen. Here I get a -6x. Here I get a +2x. When I combine them, I do indeed get a -4x. Good. Okay, so we're ready to go. As soon as there's a use for us. Okay, so I want a graph, so I've got a 3rd degree polynomial function. Let me go back up and remember my lead coefficient again was a 1, so it's positive, so my end behavior looks like that. I'm going to get my y-intercept from up here, because it just makes it a little bit easier. So here's my constant term, so that wasn't what I wanted to do. I wanted to use the magic pen. That's my constant term, so my y-intercept is -48. All right, let me go back to here and change my pen. Thanks. So we've got -48. So my y-intercept is 0, -48. And my zeros of g of x are x equals -4, x equals -2, and x equals 6. And they're all multiplicity 1. So in our next lesson, we'll do some of higher multiplicity. All right, so let me get a graph. And let's sketch this. Again, I'm just making sure I have the zeros, the y-intercept, and the correct end behavior. So I've got a 0 at -2. I've got a 0 at -4. And a 0 at +6. I know my end behavior as it starts down goes up. And I've got a y-intercept at -48. Okay, let's put that there. Switch colors. And so we look something like that. Okay, great. That's the end of the lesson on synthetic division.